Today we're doing section 4.6, day 1, and we're going to be discussing how to graph cosecant. So you're going to notice the setup is exactly the same. Again, it just comes down to the graph that is different. Cosecant is the reciprocal of sine, so keep that in mind when we go to do our picture. So A is 2, B is 2, C is 0. So my amplitude is 2, my starting point is 0, my period is 2 pi over 2, which is pi, and period over 4 is what we're adding each time. So my x1 is 0, and we have pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and lastly 4 pi over 4, which I'm just going to reduce it to be pi. So now we're going to get this information on the graph. Just a little heads up, my graph is a little different than yours. So you have it all labeled. You can see where 0, where pi over 2 is, where pi, and so forth. So mine's just a little bit more squished together, but I think you guys can handle this and modify. So my x1 value is 0, and because this is a sine wave, it's going to be an x-intercept. Then my next value is pi over 4, so that's halfway between 0 and pi over 2. My amplitude's positive, so it'll be at a max. Again, your graph is going to be more spread out, and your graph is going to be taller, just the way the picture I gave to you. Pi over 2 is back to an intercept. 3 pi over 4 is a minimum, and pi is a intercept. So I want you to continue the pattern for the entire length of your graph. So you're just going to keep going with this pattern until the whole picture is filled out. Your picture will not allow for as many periods as mine. So yours will be a little bit shorter, and that's fine. So actually, I just goofed. So that is actually supposed to be a dotted line. So when you connect those dots, this is actually supposed to be a dotted line because the sine wave really isn't there. We're just using it to base our answer off of. So I'm just going to make mine dotted. It's beautiful, right? Okay, so now that I have my dotted sine wave, I have the general idea. We need to add asymptotes, and asymptotes will occur on the x-intercept. So every time you have a dot on the x-intercept, you're going to be drawing an asymptote. So this is a vertical line. The reason the asymptote is going to be appearing is that we know the relationship between sine and cosecant are the inverse of one another. So that means I flip the fraction. So when I go to flip the value of 0, I end up getting undefined, and that's why this asymptote appears. So now that I have this flipped, or the asymptotes on there, the last thing that we have to do is flip the picture. So you're going to focus between the asymptotes. You're going to put a dot at the max here, and we are going to flip it further up, and it's going towards the asymptote. Down here, we put a dot on this minimum, and I'm going to reflect it further down. So think about we're reflecting away from the x-axis. So here we have going up, and we flip up. Down here, we're going to reflect down, and so forth. Now again, your picture, you don't have as many, because you couldn't put as many periods on it, but you can get the idea. Okay, so this one would be just a half of a U. This one would be a full. So now we got to talk about the domain and the range. So the domain is still going to be negative infinity to infinity, but now we have to restrict some values. So we're just going to write the word except. And we got to basically say where we have these asymptotes happening. So all these asymptotes are happening at multiples of pi over 2. And we'll do some practice on that domain in class. My range is now not going to be between two values. It's actually going to be the opposite. So my range is now negative infinity to negative 2 union 2 to infinity. So now it's really everything except that negative 2 to 2. So if you were to look at this on an actual graph, the stuff that I have in blue is the only part that would appear on your picture. So let's try one more. So here my equation is y equals negative cosecant of x over 2. My amplitude is negative 1. My starting point is 0. My period is 2 pi over my b value of 1/2. If I keep change flip, it'll become 2 pi times 2. So my period is 4 pi. 4 pi divided by 4 leaves us with pi. So this is a nice easy one. I have 0, pi, 2 pi, 3 pi, and 4 pi for my 5x values. So let's go ahead and get this on a graph. Again, your picture is different than mine. Yours is more spread out, so just plot your points accordingly. So x is 0, and it's going to be an intercept. At pi, I'm going down to a minimum of negative 1. At 2 pi, I'm back to an intercept. At 3 pi, I'm at a maximum, and then I'm at a minimum. And go ahead and finish the rest of the picture. So keep filling in the dots. And over here at max. Okay, so I'm going to do it right this time. So now when you connect the dots, you're going to use a dotted line because the sine wave is there just as a guide. It's not really our final answer. And now we got to put our asymptotes on there. So let me pull up my red pen. So my asymptotes are on my x-intercepts. So here is an asymptote at 2 pi. I have an asymptote at 4 pi. And then the next one is 6 pi. Okay, and now to finish the picture, so we would go in between the asymptotes. You would put a dot at your minimum value, and you're reflecting away from the x-axis, so you're going towards the asymptote. Up here, we put a dot on our maximum, and we are going towards the asymptotes. Same thing over here. We're going towards the asymptotes. This one will just look like a half of a U, and this one will also look like half of a U. Obviously, if we graph more of the period, you would see the rest of the U. So my domain is negative infinity to infinity, except, so yes, this will always have an exception. So except multiples of 2 pi. So notice every 2 pi is where we have an x-intercept. So it's at 0, 2 pi, 4 pi, 6 pi. The next time would be 8 pi. My range is negative infinity to negative 1, union 1 to infinity. And that's all for today. We'll pick up on this tomorrow.